Hello, my name is Dragan Savic and I'm here on behalf of the EWRI ASCA Water Distribution Systems Analysis History Project. Today is 24th of July 2018. We are at WDSA CCWI 2018 conference, and today's interview is with Professor Pedro Iglesias Rey. My first question for you, Pedro, is how did you get into water distribution systems analysis research field?
Oh, Dragan, is a good question. Originally, I studied industrial engineering, which is very far from water distribution system. And industrial engineering in Spain is not the same as in the rest of the world. The rest of the world, you understand, people related with organizing an enterprise, looking for moving the workers, studying timetables, hours. But industrial engineering in Spain is a bit different. It's a mixture between electrical, mechanical, construction, all together. So it looks like a strange origin to end with water distribution system, but in fact, all related with water distribution system in Spain is more related with industrial engineering than with civil engineering, that in Spain is more related with hydrology, water management, channels, and not specifically with pipe pressurized systems. I can avoid, we have a special industrial orientation also in the subjects I have or in my specific courses, because one of the main subjects is fluid systems, where I try to explain water distribution system, drainage system, but also I have to explain ventilation system, fire protection, gas and fuel installation. So it's a part of a more complex, which is all related with fluids, not specifically with water. Also in our research lane, we are specialized in water distribution system analysis. How do I finish here? Okay, because at the end, if I have to say everybody what you are, no, I'm an electrical engineer, because I study, specialize in electric. I made everything related with electric machines and so on. And one day I discovered hydraulics. I started to work in the department of hydraulic engineering, and I decided to continue working in that field. I made a master about efficient use of water. And at the beginning of my career, we were not centered in the academic area. It was more a work as inside the university, but as a consultant. We made a lot of projects, a lot of studies, a lot of research. We developed software, but not a specific research related with attending conference, publishing papers, and so on. No? It was about, in fact, I finished my PhD studies later. I had two daughters when I finished my studies. It was related with hydraulic transients in water distribution system. I developed a model to generalize the boundary condition to analyze water hammer in order to solve a unique set of equations massively, intensively, and so fast, and you have only to change several coefficients in order to adapt to a pump, to a valve, or to different tranches. What's so effective so fast? It was around 2008, more or less, when I started to have my first PhD students. When I decided, okay, we have to now to get focus in research area. We start to work mainly in modeling. We have developed a lot of software related with EPA-NET and adaptations of EPA-NET. We developed a lot of code, for example, extending capabilities of EPA-NET. Okay, mainly in the Spanish version of EPA, you know, okay, not in the English version, probably an error for the whole community, as I said sometimes. But we made an intense effort to both develop code and make a lot of continued training for engineers or for professionals in mainly in our country and a big part in South America. We have been a lot of times in South America. In fact, I made a short postdoc in South America, in Brazil, in Jopeso, in the Federal University of Paraíba. Okay, it was a good opportunity they gave me. As I said, in 2008, more or less, we decided, okay, well, we have to change our way of thinking. It was so very applied, very oriented to training, to professionals, but we decided to make a more intensive research, more academic research. Okay, to think about, to be in important conferences, to publish papers. That's why we focus mainly in two main fields: in modeling, what we made everything related with modeling. I think with our main specialized, we try to modelize everything, and optimization. Okay, and that's our main. I think our main papers are related with this. We have made papers related with optimization, with pipe optimization, with optimization, hydric and energetic optimization of water distribution system. We have made some adaptations, for example, of stored water management model to make optimization, to rehabilitation of drainage networks. I don't know, it's more or less the things I can say about our research line.
Okay, how about you have a relatively large group working in the field. Can you tell us a little bit more of your current research interest and where the group is going?
Yeah. Okay, well, as I said, the main interest is all related with urban hydraulics. In fact, in the past we had several postgraduate degrees, several master degrees, and all of them are related with we take the water from the source until we arrive to the wastewater treatment plant. All inside is our field. Okay. Mainly our main idea is to be able to modelize every part of the system. We think the modeling is one of the science of the future. We have been developing a lot during these years. At the beginning, nobody knows what's a mathematical model. They thought it's a typical thing from the people from the universities who are very theoretic. They are not practice. Okay. Nowadays that they have the people is discovering this. Okay, model are practice to represent reality to be able to predict the behavior of system from outside the normal point. Okay. And we also have been working in optimization. Okay, so it's how everything related with optimization of the system, everything in fact, we always say we say we are optimizers. Okay, we try to optimize everything. Okay, everything we could. So probably arriving to the illness maybe.
Good. I know that one of the latest pieces of work you've done is related to the best kind of energy optimization of networks, and I also know that you won the competition of sectorization.
Yeah, okay.
So can you tell us a bit more about that type of work that you do?
Yeah, okay. In fact, one of the things has moved us a lot during last years has been the series of battle networks. Okay, I think in our feeling we are competitive. I think, and that's the idea that moved us to develop a lot of things. No? I think the first time we participated in a battle was in Adelaide in 2012. It was something scary for us because we arrived there. Okay, I was telling one of my colleagues, okay, do you know we are going to be I don't know, was going to be ridiculous or no? Because we have a great expectation about our capacity to make something. In fact, it was not so bad. Okay, and the last word you say was really fascinating because it was a real problem. A very big network. I don't remember, around 13,000 nodes more or less. It's a big model, and we had to obtain a feasible solution, which is one of the more complex things in the problem. So I think the idea we try to show in this work is, okay, it's not only you not only need an optimization model. You have to use engineering judgment always, because it's not only to use a tool put inside and you are going to obtain the solution. You have to prepare the solution, because in the way you prepare the solution is the key of the success of your methodology. So, and that's what we try to show in this project. That's, I think, is one of the keys of the success of this battle. Was we try not to think in okay, in the criteria. We had to try to think, okay, what's the solution the water company would like to obtain, okay, at the end, okay? Because there were restrictions. I don't remember the number of DMAs, which was too low, and we decided, okay, this is not important. So we were trying to use another different criteria, which is completely different, but at the end it was a good solution, I think.
Very good. My last question for you is, with climate change looming and increased population and all the changes, and we have finite kind of water resources, what are the challenges for Pedro and his group in the future?
We are working in some projects related with climate change. I think nobody nowadays can doubt about these effects. Our main challenges are related to adapt, all related with climate change and new technologies to our field, okay? Modeling and optimization. We have now restrictions about the quantity of water, but now we are expecting new technologies. I think our field is not really prepared to two new technologies where we are coming, which are nanotechnology and robotics. Probably in the future we will obtain a kind of nanotechnology inside the pipes with thousands and thousands of sensors giving you information, and the kind of modeling is not related with how is topology of the network, where the network. It doesn't matter. You are going to deal with a lot of big data in order to obtain models. Probably we'll have to use machine learning to develop new models, not based in the physics or in the real model, but at the end that characterizes perfectly the behavior of the network. Okay.
Thank you, Pedro, for today's interview and sharing your thoughts with the Water Distribution Systems Analysis History Project.
Thank you to you for giving me the opportunity. Thank you.